Hey, it's Daryl from the Pixel Farm, and in this video I'm going to take you through the boybridge shot. Now, most of you have probably seen this in any one of the other various videos that I've done to demonstrate the basic functionality of PFDepth. But what I thought I would do is take you through the boybridge shot from start to finish and show you all the different things that I did to get the shot finished off. So the first thing we want to do, as always, is set up the basic information about the shot itself and our world space. And for that we're using our clip input node, and we're going to give it some basic parameters. First thing I always start with is the film back, or the imaging sensor size. Now, I've got it set to my preset for the Canon 7D. If I had to set something from scratch, what I can do is go over to the custom preset and then put in the known values that I have. So for this camera, the imaging sensor is 22.3 millimeters on the horizontal axis, and since the pixel aspect is 1:1, it's automatically going to assign the vertical based on the resolution of the shot, and it's going to give it a value of 12.54. And if I want to save that, I can just say save the preset, and then it's available to me as one of my selectable camera presets. Next thing we want to do is give it a focal length. Now, the 7D basically has an equivalent 35 millimeter motion picture film imaging sensor size, so there really isn't much of a focal length magnifier, so just putting in the recorded focal length of 40 millimeters is probably going to be fine. And we're not doing match moving and CG integration with this. If I was doing that stuff, obviously I'd want to put in something a lot more accurate based on the focal length magnifier, based on the crop value of the sensor itself, but in this case it's not really going to come into play. Next thing we want to do is set the near and the far plane values. So this assigns our world space, so I've set it to 6 feet by 50 feet. Now we know that the background is a heck of a lot further back than 50 feet. But the question is the eye even going to be able to resolve any of this stuff anyway? So I'm just going to work in a little bit of a tighter space, assign it to 50 feet, and the scene units is defined in my preferences under the Generals tab under Scene Units, and I can assign it to anything that I want, but as I say, we're going to work in feet for this demonstration. Other things that I could set if I wanted to change the input and the output frame range that I wanted to work with, I could do that. We can change the frame rate if we want to. All of those different things that define the shot, dealing with the interlacing, all that kind of stuff. Also, if we wanted to import a tracked camera that we tracked in, say, PFMatch to PFTrack, we could do that through the import FBX, but this is a static shot. So the next thing we want to do is, since we can't track a camera, what we need to do is orient a camera inside of our world space. And to do that, I'm going to right-click on the clip input node, and I'm going to select Orient Scene. And for the Orient Scene node, I'm going to change the edit mode over to Axis. And that gives me X, Y, and Z axis lines that I can line up against reference areas inside of the shot itself. So I'm going to turn off the Y-axis and the Z-axis, and I'm going to start working with just the X-axis. And for this, what I'm going to do is start lining this up on any kind of a straight line reference that I've got. In this case, I've got all of these paving tiles. So I'm going to grab that axis, and then holding down the Shift key, I can very accurately place it exactly where I want that point to be. And then we have to go over to the other side and grab the axis again. Just make sure we're along a straight line, which we are, and then we can zoom in, and I'm going to place it right here. And for each axis, we need 2 lines of reference. So we'll grab another one of these, and for this one, I'm going to place it right here. And then we'll zoom in and accurately place this one right here. Okay, so there's our X-axis, and the next thing we're going to want to do is the Z-axis. And for this, let's place this along here. And same thing for one along this side as well. Okay, so that's basically got it. And if we wanted to check this, what we could do is switch over to our translate, and we've got a great straight line reference right up here along the bottom edge of that wall. So I could move that up there, and we can see that it's, the rotation is a little bit off. And that's because we haven't applied any lens distortion correction here, so there might be warping a little bit. So what I can do is switch over to rotate, and I'm just going to rotate that over so it's lined up just a little bit better. And maybe we'll also just make a slight adjustment on the Z orientation. I'm just eyeballing this as best I can. And that's looking pretty good. Most of these lines are lined up against these paving tiles. So the next thing we want to do is set what we have as far as known camera orientation, such as how high was the camera off the ground. In this case, it was about 4.5 feet. And how far back from the scene was it? Well, I know it was approximately 20 feet, so let's go 20 feet. Actually, let's go 20 feet, not minus 20 feet. And after that's been placed, what I want the center of the universe to be is approximately where, between the boy's legs as he's walking. So I could translate this again slightly. I'm just going to move this back a bit so that it is around there, approximately. So that's pretty good. So that gives me my basic scene orientation. The next thing we need to do is start setting up all of the individual layers, and you've seen me do this before. What I'm going to do is just right click and I'm going to say ZDepth object, which is going to bring in my ZDepth object node. And there's a number of things that we're going to need to set up for this. We're going to use hierarchies to identify groups of segmented layers, such as on the boy, these pillars back here, and the chain, the wall, of course, the ground, all of this kind of stuff. So let's start building these layers up. So we're going to create a layer, and I'm going to call this boy head. And it's just throwing it out in space, and I'm not going to concern myself with any specific depth assignment right now. We're going to take care of all of that later. And as you know, we could either draw an X-spline or draw a Bezier. What I'm going to do is use the paint tool, and with the paint tool, if I select paint boundary, you can see here that I've got a stylus, and the stylus is defined by the brush size. So what's going to happen is you've seen how I've painted this in, and it's automatically doing an analysis between the inner and outer mass shapes. If I was to call this back a little bit, let's bring it back to, say, a value of 10. Now I've got a smaller shape. So now if I paint that in, it's going to give me a slightly smaller area for analysis and comparison. And then hitting the escape button to close it off, I can now turn on show color, and we can see how it's doing as far as doing that automatic rotoscoping. I can then refine this any number of different ways that I like. I can adjust the edge width, the edge smoothness. So if I wanted to make the edge a little bit bigger, I just increase the size and say set, and you can see now that it's grown out just a little bit. And likewise, I can shrink it down if I like. Say a value of about 15 is looking pretty good. I can adjust the edge fall off, so making adjustments to this is either going to erode or dilate that shape. And we've basically got that set up. So next thing we want to do is switch over to the tracking tab, and we're going to take this basic X-spline and track it into the rest of the scene. Now there's a number of different parameters here, and I'm not going to go through all of them. You can refer to the user guide under the ZDepth object node reference to find out what all of these individual things do. But what I'm going to do is I'm going to use translation because he's just walking from left to right. There isn't going to be a lot of perspective, but I could turn on perspective tracking, illumination if it was, there was HMI flicker and that type of stuff. If the image was shearing, rotating, all that kind of thing, all that kind of stuff. What I am going to turn on is depth. And the reason I'm going to turn on depth is because there is a lot of stuff going on in depth. And I don't want occluding objects and all that kind of stuff to get thrown off. So, I might not necessarily need it, but I'm going to just turn on for the sake of having it. And then I'm going to start tracking this forward. So I'm going to track it until he walks out of frame, and then it's going to lose its track and it's going to stop. So if we were to continue one more frame forward, we can see that he's no longer in that frame. So I can now set this as my out point, and then the mask shape is no longer valid. And then of course I can review this and just make sure that everything is working for the most part, and it looks like it is. Now we're accelerating greatly the basic process of rotoscoping these objects. You do, however, want to take the time to review what you've done and just make sure you're getting everything, because the better quality of a segmentation you're going to have for each one of these layers, ultimately the better result you're going to have downstream when you convert this into a stereoscopic image. You're not going to have a lot of this, Z fighting that could possibly be going on. We're going to continue tracking this in reverse until it stops, and it stopped there. And there's the first time we see him, so we're going to say that is our endpoint. And then that shape is gone. And again, we want to go through and just review how well it's doing its job. Now there's some stuff going on here because of the background fighting with the foreground here because of this, this pillar. So what I can do is just adjust the opacity down a bit and make some changes to the shape. So we're getting rid of that issue. I can even add additional points in here if I want to. Again, just adjusting the transparency to see how things are going. Adjust that up a little bit. Okay, so that's a bit better. And we'll just continue forward. And over here, we'll see if we're good. Cool. All right. So that's the boy's head done. And the difference in doing it this way versus the way you would traditionally do rotoscoping is all managed by the edge type. I've got it set to adaptive, and that's what's doing this foreground versus background analysis and doing all of the detail work for me. If this was in hard edge mode, obviously you're getting a hard edge. There is no gradient. And if it is in soft edge, you're getting a gradient between the inner and the outer lines. But again, you're going to have to do all detailed rotoscoping in order to separate this object. Using the adaptive mode, it's doing all of that work for us. So now that we've got his head tracked in, what we might want to do is start working on an area such as his torso. So for that, I'm going to keep his head selected and create a new layer. And now we're creating a child layer of his head layer. So his head layer is acting as the parent. And in this case, I'm going to call this torso. And what I want to do is, again, paint in a shape for that area of his body. So I'm going to paint in the area of his torso. And again, switch over to the tracking tab. And we're going to track this forward. Now, I know that we're going to have to do some adjustment for this because his arm is going to be swinging in front of all of this area. So, it should do a fairly good job, but we're going to want to, of course, go back and just double check that it is just identifying his torso. So now we are basically up, but we can see here that the back of his shirt is still in frame. So what I'm going to do is just make some adjustments to that one area. and it's still catching everything else. And now I can say that is the out point. So if I turn edit off, you can see that the line goes away and I can no longer do anything. But if edit is active, I have access to all of the individual points on that X-spline. So if things are starting to fall off, as they are here, as I mentioned, I knew that we were going to have to do a little bit of adjustment. I can just go back in and make those changes, and a keyframe is added to our timeline to account for that adjustment. And here it's kind of fighting with that pillar, so we'll spend a little bit of time separating this properly. And we can continue back. And again, because this is doing all of the detail work, the only time I have to go back in and work on something is when I feel that it's a strong enough change, again, because it is doing all of this analysis and doing all this detail work. You know, it's kind of down to me to decide whether or not I want to make that adjustment, because I want a little bit of a finer detail acquisition of the pixels that are part of the object that we're working on. But the main point is that, you know, versus a traditional rotoscoping workflow where, you know, I'm drawing a shape, then I'm going, you know, 10 frames forward, then I'm going 5 frames back, and all that kind of stuff. You're sort of going back and forth to try and refine the shape. This is doing all of the vast majority of that, so I'm only going in and making minor adjustments. And again, we're also dealing with motion blur here, so we're just going to try and get that best that I could. Now, one cool thing about PFDepth is you can have somebody in your facility who is concentrating more on the rotoscoping side of layer segmentation and doing all of this stuff, and then when the conversion artist starts working on the shot, they can basically grab all of those rotos and bring them in. Now, there's a couple of different ways you can do that. You can use Silhouette Roto and support all of the splines in here. You can use Imagineer's Mocha, but you can also use PFDepth. So if I have a whole list of roto shapes, I can export those out and give them access, and give that access to other artists to bring those layers into their project. And I've done that for all of the work that I've done here. I'm not going to make you sit through me going through and rotoscoping all of this stuff. So what I could do is, if I wanted to, let's just, you know, delete everything that we've done so far. I can say import, and then I can point to where that ZDepth object information is. And I've got one here called objects no depth. And that is just all of the rotoscoping. I haven't done any depth assignment to any of those layers. So I can open that, and all of those layers now come into PFDepth already done for us. And I'm going to give you these as well, so that so you can sort of test that out. So we can see here that basically everything is assigned to 28, unless it's a child layer. In that case, it's a depth assignment of 0, because we're using the parent layer as the depth assignment, and everything else is a minor offset of that parent layer. So now what we need to do is go through and start defining where individual layers are going to live in Z-space, and how any associated layer is going to be offset from its parent. So what I want to do first is let's take a look at the boy. Now the boy, we know that when we set up our orient scene node, we basically set it up so that he is approximately, where's our orient scene node? He's approximately 19.5 feet away from camera. So for his head, I'm going to say that it should be about 19.5 away from camera. And then when I take a look at this in Z-space, he's now been extruded forward. He's totally flat, but he's now sort of standing out there in my scene, extruded from the background. Now I want to go through and start setting everything else up relative to him. So we set up a world space of 50 feet. So for the background, I'm going to want it to be as far back as it can be. So I'm going to say that that should be 50 feet back. So there's the background. The wall, these layers can all be grabbed and moved kind of dynamically back and forth. But I took a lot of measurements when I was on set, and I know that the wall is approximately 24 feet away back from camera. And you can see how, that's reasonable to assume that the wall is kind of sitting there relative to where our boy is in the scene. The left pillar, we're going to say is approximately, well, let's say it's about 28 feet, and that's what it's set to right now, so we'll leave that. And the right pillar is coplanar with the left pillar, so we're not going to change that. We're going to leave it as a value of 0. But the chain is about a half a foot offset from the front of the pillar. So what we're going to do is say that that is minus 0.5. Actually 0.5 rather, because we want to push it back. So there it is. So now if we start working on the boy, we need to figure out, approximately how far forward is things like his torso. So the torso, I'm going to say, and this is all going to come into play with thickness and depth modifiers and all these other different things. So I'm going to say that his torso is minus 0.4. So we're just pulling his torso forward from his head a little bit. And his right arm, we're going to say is minus 0.65. And that pulls his right arm forward, as you can see here. And his left arm, we're going to say is minus 0.08. So that's just going to give us a little bit of offset that we can start working with some stuff. His right leg is minus 0.7. And his left leg is, let's say, 0.1. That's just going to push his leg back. Now, we've got all of these different depth values set up for the boy, and now what we want to do is start working on how they're going to, have their shape altered so they look a little bit more realistic relative to the camera. And the way that we're going to do that is by adding some thickness and some depth modifiers to these. So if we go back up to the boy's head, if we want to start adjusting thickness, we can, start moving the inner thickness value and start pulling it forward and pushing it back. Or we can, of course, add things in numerically, and I've already taken the time to figure out how I want these to be. As I mentioned, I'm sort of taking you through what I've already done, so you can do it on your own. So what we're going to do here is add a value of minus 0.35 for the thickness of his head, and that's just going to push that back. And then we're going to switch over to the modifiers tab, and for this I'm going to use a radial modifier. So the first thing I want to do is select the modify button, so that's going to give me access to the layer itself. And I'm just going to start to change the shape of this so it's kind of encompassing his head. Kind of like that. So the thickness I've set to 0.2, and the depth blur radius I'm going to set to a value of 20. And what that's going to do is take that layer, sorry, minus 20 because we want to pull it forward. and pull it forward. There we go. So now what we're trying to do is create this kind of cylindrical shape, and you can see what happened there. I just put in the wrong value for the thickness. It should actually be a value of 0.2 as opposed to a value of -2, because by having a negative value, it's going to suck it back into itself, but we want to pull it forward. So again, a value of 0.2. So there's some shape to his head. The next thing we want to do is work on his torso. And the thickness for his torso I figured should be about -0.35. And switching over to the modifiers tab, I'm not using an actual modifier, but what I am doing is using the depth of blur radius. I'm setting this to a value of 20. And that's creating a little bit of curvature to his torso. But I'm also going to use the image map modifier, and this is going to use the luminance values to create essentially a bump map. And I want this to be, not over pronounced. I'm going to have it as a value of, say, -0.8, and then an offset of 0.8. So we're pulling it forward and then adjusting the depth offset. So now you can see in doing that, his head is kind of sitting on his shoulders, and we've got a nice curved shape for his torso. And you can, of course, experiment with different values to see how they interact with the shape. But I'm just trying to take you through the values that I had and how they're reacting with the individual layer. Switching over to his right arm, I gave it a thickness value of -0.45. And on the depth modifier, we're setting a depth blur radius of 30. And I'm dilating this by a value of 10. And again, using the image map modifier, I'm giving a value of -1 and +1. So now there's his arm. So let's work on his left arm as well. The thickness is -0.35. And for the modifiers, we're using a depth radius of 20 and a dilation of value of 3. And then again, using the image map modifier, -1 and +1. There we can see his left arm is kind of in behind there. Or it's only coming up from the side of his body, so you're only really seeing it here at this point. Now we're going to work on his legs, of course, and his right leg, the edge, or the thickness, is -0.45. And the depth modifier, we're using a depth radius of 30, and that's giving us the curvature. And the dilate, it's a value of 10. And then the image map modifier, we're using, again, -1 and 1. -1. There we go. And we'll do the left leg as well. The thickness is -0.35. Depth blur radius of 30. Depth dilate of 10. And image map is, again, -1 and 1. So there is the shape that we've created for the boy as he's walking through the scene. So we can scroll through and see how that's reacting. The ground, what I did is, if I turn on the ground plane, I'm using the modifier called planar 3D. And it's literally just taking that ground plane and sticking it to the ground. It doesn't matter what the depth value is or any of that kind of stuff. It's literally just taking that layer and sticking it to the ground. So now let's go back up to the wall. And for the wall, we've got, again, 24 feet away from camera for the wall. The thickness, I'm going to give it a value of minus 1.3. And for the modifier, we are using a depth blur radius of minus 5. And the image map modifier is what's going to give it all of that aggregate surface. So we're using a value of 0.65. You can see how that's reacting with that. And for the image map offset, we're using a value of 0.4. Cool. Now for the background, we've already given it a depth assignment of 50. So what I'm going to do is extrude that background. Well, first of all, let's give it its modifier. We're going to give it a ramp modifier. And now I'm going to start to pull this forward until it's sitting behind the wall, and that's approximately 24 feet away from camera. You can see where it is there. So let's say 24. And then what I want to do, I'm going to turn off show all objects. All I really want to concern myself right now with is the wall. Because what I want to do is, by going back to the modifier and selecting modify, what I can do is change the position of this modifier and just start to bring this up. And what I want it to do is kind of vanish at that horizon line with that landmass in the background. So I can bring that up until, and I'm just looking right here, until that land is no longer stretching forward. And I know at that point I'm at my horizon. So what's happening is that background, I can stretch this forward just to create more of a curved layer. But basically what's happening is this background is now starting to vanish off in 3D space. So this is going to create an even more of an illusion of depth when we convert this into 3D, because it's no longer just a postcard in space in the background. That layer is literally starting to go off in 3D space and then comes to basically a flat surface all the way back here. So let's turn back on show all objects. And what I'm going to do is that wall, let's go back to the wall. Again, because everything's so interactive, what do I want is for that wall to, of course, be touching that ground. So I'm just going to start to push the wall back until it's flat. And then I can move it forward and do all those kind of minor adjustments and that kind of thing. But I want it to basically be touching. You can see how interactive this is. You know, I can make all these kinds of adjustments and have everything just move right along with me and give me the look that I'm ultimately looking for. Cool. All right, so now what I want to do is I want to check out where his feet are, and I can see that his feet are kind of being buried into the ground. So for the boy, again, I can grab the boy's head layer and start to move him forward until his back foot is no longer being buried in the ground, and his foot should be planted, obviously, because we can see here it's actually touching the ground. So I can move that until his foot is basically in contact with the ground. And that's looking a little bit better. So I can scroll forward now to a point where his front foot It's touching the ground. Now this is how we're testing whether or not that planar 3D layer is actually reacting properly with our ground plane as we've oriented it. And of course we can always make adjustments to this. But what I could also choose to do is if I wanted to use a ramp for the ground, I could switch over to ramp and just pull the ground forward, modify the ramp. Adjust the thickness of it. And then in doing that, we're actually fixing that, that little problem. Of his foot not actually coming in contact with it. Again, we'll go back to the Modify tab and smooth out that bottom portion. And just continue to extrude it forward until his foot's in contact. Like it is now. So again, you're free to experiment the way the way that you see fit. What you want to do is try and find the happy medium between creating something that looks geometrically correct, while also keeping in mind what can the eye actually resolve. Taking the time to figure out where his foot is being planted on the ground is worth taking the time. We don't want to make it look like he's kind of floating out in space. So in doing this, I'm just kind of interactively making adjustments. I naturally want the wall or the ground to come in contact with the wall while it's still coming in contact with the ground. So we're just making those adjustments. And then I want to sort out this kind of lip that's kind of hanging over, and we'll just use the position of the image map modifier to correct that. Cool. So that's the ground sorted out then. Again, we can scroll through this and just make sure that his footfalls are still planting, and they basically are. I could take the time to make a few more adjustments to this if I wanted to, but that for the most part is pretty good. So the next thing we want to work on is these pillars here in the background. So again, the left pillar is acting as the parent for the right pillar in the chain. So for that left pillar, what I'm going to do is give it a thickness of, say, 1.2. And for the modifier, I'm going to use, we're going to use a cylinder modifier and turn on the Modify tab, and I'm just going to bring this in a bit. And you can see as I'm doing this, it's changing the shape of that pillar. And we'll do the same for the other side. So again, it's going to inherit the basic value. So I can select that and say copy. Then I'm going to paste that value there. Go back over to the modifier, select cylinder, modify the shape. And you can see here as I make a modification to that shape, how it's interacting with my pillar. So the next thing is, of course, the chain. For the chain, I've given it a thickness value of minus 0.6. And for the modifier, I'm actually not going to use a depth modifier. What I am going to do is switch over to my detail keyer. And what the detail keyer allows me to do is, as you can see, we've got the pixels sort of coming through the center. Whether or not you're going to be able to resolve that is kind of up to you to decide. But what I'm going to do is say enable detail keyer, and I'm going to sample the background and start to poke the holes into that layer. I'm going to turn off show color. Let's leave that turned on. So I'm sampling that area. And you can see that it's now starting to cut those holes in the chain link. And what I can do is start making adjustments to the threshold and the smoothness. So as I start to bump this up, you can see how it's adding in additional pixels here. And we just want to try and get it to a point where it's getting the vast majority of it. And it looks like it's basically there. And then I can start bumping up the smoothness, and of course that's going to smooth out the edges, say about a value of 70. Now we can see that the depth assignment is incorrect, so again we can go back to the Edit tab, and we can pull that forward, literally by grabbing that forward piece and moving it forward until it's positioned approximately where we feel it would be on those pillars. So approximately there. So we've gone through and added all of this depth and shape to this object. And to me, it's kind of looking like his leg's a little bit too far back. So let's select his left leg, and let's move his left leg forward. Yeah, that's looking better to me. We want these offsets to be relatively close to where they would be in the real world. Okay, so we've got all of our depth, and our scene is basically built out now. So what we can do is now add in a stereo render node. And the stereo render node is what is going to create our stereoscopic scene. So if you're working with anaglyph glasses, you can take a look at this as an anaglyph. I'm just putting mine on right now as I'm speaking to you. And you can start to see whether or not things are making sense. And there's a bunch of different adjustments that you can do, that you can use in the stereo render node that's going to change how you're looking at this. First, of course, is interocular separation. We've set this as a value of 0.065 feet, so which is roughly the distance between your left eye and your right eye on average. The next thing we want to do is adjust the convergence. So right now we're converging somewhere back here, and the way that we see that is by going back over to our perspective view, and this turquoise box is showing us where we're currently converging. So I can make an adjustment to this by dragging. I can type in a value, so say we want to give it a value of, say 20. And now it's a little bit further up. But what I can also do is just hold down my Command key here on my Mac and drag this forward and position this specifically where I want it to converge. In this case, I want it to converge on our boy. So you can sort of see how dynamically this is making those changes. So I want this to converge right on our boy like it is now. Okay. And the other thing I can do is turn on the disparity histogram. And this is giving me a measure of the amount of stereo disparity and where the majority of the disparity is actually happening in Z-space. So 0 is essentially the screen. So anything below that is coming forward, and anything beyond that is being pushed back. So if I wanted to increase the stereoscopic effect of this, I could use the disparity scale value and start to bump that up. And when I do that, you can see that there appears to be significantly more depth into the scene. And we can also adjust the disparity offset. So if we wanted to have more coming out of the screen, I could push the screen further back into the scene if I wanted to. So let's say we wanted our boy to be the center point, and this is roughly where our boy is right here. I could match up the disparity offset so that it's on him. So now the ground plane is extruding from the screen. He is basically at the screen, and anything beyond him is being pushed back. So the next thing we can do is we can start working with the in-painting tools. So the first thing I'm going to do is start to adjust the dilation of this, basically because you can see right here there's a whole bunch of edge chatter going on. So if I adjust the edge dilation, it starts to cull that back in. I can then adjust the edge softness and solve more of that and just smooth out those edges. I can also adjust look ahead values. So right now we're not looking ahead at all. Everything that I'm doing is on the current frame. But if I wanted to do temporal analysis for my in-painting, I could adjust this to a value of 1. And with a value of 1 in my step, we're actually now comparing across 2 frames. If I bump it up to 2, now let's say we bump it up to 3. We're stepping 1 frame forward, so we're basically analyzing in every single frame. But if I wanted to analyze in every other frame, then I can bump this up to a value of 2. And now we're no longer analyzing all of these temporal vectors across every single frame. So we're conserving a little bit of bandwidth while still giving us the same frame range of analysis. But anyway, you can see here we've got our scene. We can check this out as the left eye only. We can check out the right eye only. It takes a second for it to click in because of the temporal analysis of the in-painting. So there is our left eye, there is our right eye, and here is our anaglyph. And we can turn off our stereo disparity histogram, cache those into RAM as it plays back. So that's essentially the boy bridge shot, taken from start to finish. Now I kind of encourage you to go through and experiment with different depth modifiers, play around with different depth values, and just kind of see how interactively you can make adjustments to all of this stuff and ultimately achieve whatever result you're going for both the look of things in stereo as well as the amount of stereoscopic effect you want to have in your scene. So thanks a lot for watching, and we'll see you in the next video.